Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to find powers of monomials. We're going to be applying the power of a power property of exponents. This standard is covered in Algebra 1, Algebra 2, and Pre-Calculus courses. Don't forget there are 14 practice problems at the end of this presentation that we'd like you to try out to demonstrate mastery of the content covered in this presentation. If you'd like to gain access to the entire playlist and other valuable resources, just take a look in the link in the descriptions below, or you can visit our website at mathgotserved.com. Alright, before we get started, let's go ahead and review the formulas that are going to be guiding our problem solving process, okay? So we're just looking at the different variations of the power of a power property of exponents. So the first one that you need to keep in mind is if you have a power, let's say x to the a raised to the power b, your answer is going to be x to the ab. So what do you basically do? If you have a power raised to a power, you multiply the powers. Okay, so it's x to the a times b. Now what if the power that we're talking about in the parentheses involves the product of two powers? So let's say you have x to the a times y to the b, and we have the product of powers here with different bases raised to the power c. In this case, you just simply distribute this power on the outside to the powers in the parentheses. So you have x to the ac, y to the bc. Okay, all right. And lastly, what if you have a coefficient, let's say a, in there? So a x to the a, y to the b, everything raised to the power c. So you just have to remember that when you're raising a monomial to a power, that power is distributed to every single factor in the parentheses. So in the case where you have a coefficient that's not 1, it has an invisible power of 1, so you distribute that power to the coefficient also. So you have a to the c, x to the a times c, and then y to the b times c. Okay, we're going to be making use of these formulas in the following problems. Alright, so the instructions are as follows. We are to simplify the following. Simplify the following. Alright, so question number 1. Let's say we have the monomial x to the third power raised to the fourth power. Now what's that going to be? Let's go ahead and work that out. So if you have x to the third power raised to the fourth power, what do you do here? You simply multiply the powers whenever you have a power raised to a power. So it's going to be x to the 3 times 4, which is equal to x to the 12th power. All right, so there goes the answer to question number 1. All right, question 2. What if you have cd to the 4th power raised to the 2nd power? Let's take a look at what the solution is. So we have cd to the 4th power raised to the 2nd power. Now, when you have multiple factors being raised to a power, you want to specify what the power of each factor is so you can know what you're doing, okay? So c doesn't have a power, so it has the invisible power, which is just 1. If we're using the power of product of powers property here, what we're going to do is simply distribute this power to the powers in the parentheses. So this 2 gets multiplied by that 1, and then this 2 gets multiplied by that 4. Alrighty, so this becomes c raised to the 1 times 2, d raised to the 4 times 2. If you work that out, you will end up with c raised to the 2nd power, d raised to the 8th power, as the answer to question number 2. All right, let's take a look at another example, question 3. What if we have negative 6 times m n square raised to the 3rd power? Okay, so let's see how we can solve a problem like this. So negative 6 times m n square raised to the third power. So remember that this power right here is distributed only to the terms in the parentheses. So this -6 is left untouched. All right. M doesn't have a power, so we give it the invisible power of 1. Now we're going to distribute this power 3 to 1, and we're going to distribute it to 2. It's going to be a multiplicative relationship here. Operations. So we have -6 m to the 1 times 3, n to the 2 times 3. And then if you work that out, you get -6m to the third power, n to the 6th power. And that's the answer to question number 3. Alrighty, let's take a look at question number 4. So question 4, what if you have the power of the monomial 3x to the 4th y raised to the 4th power? Let's take a look at how to do this. So we have 3x to the 4th power y raised to the 4th. Now we need to assign a power to every factor in the parentheses, okay? So 3 doesn't have a power, so we give it a power of 1. Y doesn't have a power, so we give it a power of 1. Why are we doing that? Well, because if we're using the power of product of powers property, we're going to be distributing this power to the powers here. So by specifying the power, we know exactly what we're multiplying by. So 4 gets distributed to this 1, this 4 gets distributed to this 4, and this 4 gets distributed to this 1 right here, okay? And then that becomes 3 raised to the 4th power times x raised to the 4 times 4 times y raised to the 4th power, okay? You just multiply these by 1, that's how you get it. All right, let's simplify that. This is going to yield 3 to the 4th power is 3 times 3, 9 times 3, 27 times 3, that's 81. X to the 4 times 4 is 16. Y to the 4th power. There goes the answer to question number 4. All right, moving along, question 5. Let's say we have the monomial -2x raised to the 5th power raised to the 3rd power. Let's go ahead and solve that. So we have -2x to the 5th to the 3rd. All right, so let's specify the powers here. You have 1 and then you have 5. Okay, so just a side point, something to keep in mind is that whenever you have a negative number raised to an odd power, you always have a minus. And when we have negative raised to an even power, you have a positive. Well, why is that the case? Well, because when you have negative raised to an odd power, there will always be a negative left out unpaired. All the paired negatives become positive, but the one left out stays alone, so it causes everything to be negative. Okay, so let me show you what I'm talking about here. If you have, for example, minus times minus times minus, that's 3 minuses. That's minus negative raised to the 3rd power. You can pair the first 2, which if you multiply them together, they become plus. But because of the odd nature of the number of signs, that minus that's left out would change the sign of all the pairs that form positive to become negative. Okay, so what you just have to remember is that negative raised to an odd power is going to be negative, and a negative raised to an even power is going to be positive because all the signs pair off and they all become positives. All right, so we're going to be applying that here. So the negative, the 3 will be distributed to the negative sign. It will be distributed to 1 and to 5. Now when you distribute 3 to the negative sign, basically negative raised to a 3rd power is going to be negative because, negative raised to a 3rd, yeah, it's negative because 3 is odd. And then times 2 to the 1 times 3 times x to the 5 times 3. Okay, when you simplify that, you have -2 to the 3rd times x to the 15. And then when you simplify that, what is 2 raised to the 3rd power? 2 raised to the 3rd power is 8. 8x raised to the 15th power is the answer to question number 5. All right, moving along, let's take a look at question 6. All right, for question 6, let's say we have 1/2 a raised to the 4th power, b raised to the 5th power, c raised to the 6th power, all raised to the 4th power. Okay, and then let's see what this power of a monomial will look like when it's simplified. So we have 1/2 a to the 4th, b to the 5th, c to the 6th, raised to the 4th power. So what we're going to do is we're going to go ahead and distribute this power to everything, all the factors in the parentheses, okay? All right, so this 4 will get distributed to the 1 and the 2. It'll get distributed to the 4 here, and it will get distributed to the 5 and then the 6. All right, so what's that going to look like? Well, we're going to have 1 raised to the 4th power divided by 2 raised to the 4th power times a raised to the 4 times 4, b raised to the 5 times 4, c raised to the 6 times 4. If we simplify that, we're going to have 1 raised to the 4th power is just 1, 2 raised to the 4th power is 16, and then times a raised to the 16, b raised to the 20, c raised to the 24th power. Okay, and there goes your answer for question number 6. Alrighty, let's take a look at question 7. So for question 7, what if we have the monomial -3 a to the 6b to the 3rd, all raised to the 2nd power? All right, let's go ahead and simplify that. We have -3 a to the 6th, b to the 3rd square. So we're going to distribute this minus to the sign, distribute square to the sign, distribute 2 to 3. 3 has an invisible power of 1. Okay, and then distribute the 2 to the 6, and then distribute the 2 to the 3. All right, now what happens when you raise a negative number to an even power? If you raise a negative to an even power, it's always going to be positive because they all pair up and they slash and dash and they'll become positive. So when you raise this minus to the 2nd power, it becomes positive. Okay, so it's positive 3 raised to the 1 times 2, a raised to the 6 times 2, b raised to the 3 times 2. Okay, so let's simplify that. We have 3 raised to the 2nd power, a raised to the 12th power, b raised to the 6th power. Okay, and then let's simplify further. 3 squared is just 3 times 3, which is 9. So 9a to the 12th, b to the 6th is the answer to question number 7. Alrighty, let's move on. Question number 8. What if you have the monomial -6x to the 6th, y to the 7th, raised to the 2nd power? Let's go ahead and solve that. All right, so we have -6x to the 6th power, y to the 7th square. So what we're going to do is specify the powers for each term. So -6 has the power of 1, okay? All right, so let's distribute. We're going to distribute the 2nd power to that negative sign right there. Distribute a 2 to the 1, to 6, and then 7. All right, so if you raise negative to an even power, that's going to be positive. 6 times 1 is 2. X to the 6 times 2 is 12. Y to the 7 times 2 is 14. Okay. All right, so let's go ahead and simplify that. 6 squared is 36. So we have 36x to the 12th power, y to the 14th power as the answer to question number 8. All right, number 9. What if we have the product of two monomials raised to a power? So let's say we have x to the fourth power y to the fourth square times xy to the third. Alrighty, let's go ahead and do that. So to do that, we're going to focus our attention on the power first, and then we'll shift gears and multiply it by the other monomial right here. Okay, so why do we do a power before we do a product? Remember, please excuse my dear Aunt Sally, order of operations, right? So in please excuse my dear Aunt Sally, you do the power, do the exponent before you multiply or divide. So we're gonna have to deal with this exponent first before we multiply, okay? So how do we deal with that? We will use the power of a power property to deal with this scenario right here. So that 2 gets multiplied by those two powers. So it now becomes x to the 4 times 2, y to the 4 times 2 times xy to the third power. If we simplify this 2 right here, we'll have x to the 8th, y to the 8th times xy to the third. Okay, so now we're going to use, let's put the power for x here, 1. This property we covered in the previous presentation, which is the product product property of exponents. Whenever you multiply exponents with the same base, you add the powers. If you don't remember that, just take a look at the link in the description and go and review that video to refresh your memory on the product property of exponents, okay? So we're going to combine x to the 8th and x to the first power. So it's going to be x to the 8th times x to the first times y to the 8th times y to the first. When we apply the product property of exponents here, what we're going to have is we're going to add the powers, okay? So it's going to be x to the 8 plus 1, y to the 8 plus 1. Oh, I changed it. I'm sorry, this is supposed to be a 3 right here. Changed it to a 1. So this is a 3. Okay, so that's a 3. So we have 8 plus 3. You add the powers, all right? When you simplify, you have x to the 9, y to the 11th power, and that's the final answer to question number 9. Alrighty, moving along, let's take a look at question number 10. So for question 10, let's say we have a square times the monomial raised to a power, a to the third, b raised to the fourth power. Okay, let's take a look at this one right here. So the question is, what are we going to do first? Are we going to multiply first or deal with the exponents first? Well, using order of operations, we know we're going to have to do the exponents first, okay? So to do that, let's specify the power for b, which is 1. So we're going to distribute this 4 to 3 and 1 using the power of a power property of exponents. So we have a square times a to the 12th power, b to the 4th power. Okay, and then when we simplify further, we're just going to add the powers here. So it's going to be a to the 2 plus 12, b to the 4th, and then the final answer is going to be a raised to the 14th power, b raised to the 4th power, and that's the answer to question number 10. All right, let's take a look at number 11. For number 11, what if we have negative 5a squared b to the third square times, so we have a monomial raised to a power times another monomial, 2ab to the second power raised to the second power. All right, so let's go ahead and do that. So what we're going to do is we're going to deal with the exponents in both factors first, and then when we're done, we'll then go ahead and multiply both of them together. Alrighty, okay, so for the first one, we have a 1 here, specify power is 1, 1. we're going to distribute the 2 to the 1. Also, the square gets distributed to the sign, don't forget, and then to the 2, and then to the 3. This 2 right here gets distributed to the 2, to the 1, and then the 2. When I carry out that multiplication, you're going to have 2 raised to an even power. Negative raised to an even power is positive, so it's going to be positive 5 raised to the second power is 25. A raised to the 2 times 2 is 4. B raised to the 3 times 2 is 6. Okay? Times 2 raised to the second power, which is just 4. And then A raised to the second power, B raised to the second power. All right, now we're going to combine like terms. We'll multiply 25 and 4. 25 times 4 is 100. And then we'll multiply a to the 4th and a to the 2nd power. You add the exponent, so that's a to the 6th. And then lastly, b to the 6th and b squared. You multiply them together, you have b raised, oh wait, I made a mistake here. This is supposed to be, all right, so let's go ahead and multiply that out. So we're going to have negative 5 raised to the second power is just going to be positive 25. And then we have a to the 2 times 2, which is 4, b to the 3 times 2, which is 6. That multiplied by 2 to the second power is 4. A to the second power, b squared to the second power is 4. B to the 4th power. Okay, now we're going to go ahead and combine like terms. Multiply 25 and 4. 25 times 4 is 100. And then we combine a to the 4th and a squared. Combine those two is a to the, you add the power 6. And then you combine b to the 6th and b to the 4th. You just add the powers. That's b to the 10th power. Okay, so there goes the answer to question number 11. All right, let's take a look at number 12. So for question 12, let's say we have 5a to the 4th b squared raised to the 3rd power times 1 over 5 a b squared c raised to the 2nd power. Okay, so let's go ahead and do it. All right, I'm going to put up a partition here so we don't get our work mixed up. Okay, so we're looking at 5a to the 4th b squared raised to the 3rd power times 1 over 5 ab squared c raised to the 2nd power. Okay, so what we're just going to do here is just distribute the power to the powers as we've done in previous examples. So it's going to be 5 raised to the 3rd power, a raised to the 12th, b raised to the 6th power. Okay, and then times 1/5. We're going to have 1 squared, which is 1, divided by 5 squared, which is 25. So you square the numerator and the denominator when 2 gets distributed to 1/5. And then a raised to the 2nd power, b raised to the 4th, c squared. Okay, now let's combine like terms. Oh wait, hold on. 5 to the 3rd power can be simplified, right? 5 to the 3rd power is 5 times 5, which is 25, times 5, which is 125. A to the 12, b to the 6, times 1 over 25, a squared, b to the 4th, c squared. All right, so let's go ahead and combine like terms. So when we multiply 125 by 1 over 25, we have 125 over 25. Okay, and then a raised to the 12 plus 2. All right, so 12 plus 2, and then b raised to the 6 plus 2. All right, and then we have the c. C is just raised to the 2nd power there. Okay, now we have b raised to the 6 plus 4. It's not 2, it's 4. Let's fix that. So b is raised to the 6 plus 4. All right, so let's go ahead and finish this off. If we simplify that, we are going to get 125 divided by 25 is just 5. Okay, you can check that out with your calculator, or this is 5 to the third over 5 squared. And when you subtract the powers, you have 5 to the 3 minus 2, which is just 1. A to the 14, B to the 10th power, C raised to the second power. And that's the answer to question number 12. Alrighty, let's take a look at question 13. So for question 13, let's say we are to simplify the sum of the powers of two monomials. So 7a to the 5th square plus a to the 4th times 2a raised to the 6th power. Alrighty, so let's go ahead and look at this. So here we have 7a to the 5th square plus a to the 4th, 2a to the 6th. Now the first one, we're raising 7a to the 5th to second power, so that's going to be 7 square a to the 5 times 2, which is 10. Okay, plus, now in this one right here, we're just multiplying, right? So you have a 1 here, so 1 times 2 is 2, a to the 4 plus 6, which is 10. Applying the product property of exponents, you just add the powers. All right, so let's simplify this. 7 squared is 49. We have 49a to the 10th power plus 2a to the 10th power. Now since these are like terms, we can combine them. They are coefficients of both rationals, identical variables with the same powers. So if we combine them, we just add the coefficients, which is 51, and you keep the power the same. All right, so your answer is 51a raised to the 10th power. All right, let's take a look at the last one, and then give you a chance to do some practice. Number 14. What if you were to simplify 2x squared y raised to the 5th power minus 3x to the 3rd y raised to the 2nd power times x to the 4th y to the 3rd. All right, let's go ahead and do that. So we have 2x squared y to the 5th minus 3x to the 3rd y squared times x to the 4th y to the 3rd. All right, so let's simplify. So the first one, we're going to raise all the terms to the 5th power. So we have 2 to the 5th, x to the, multiply 2 times 5, 10, y to the 5th. Okay, minus, and then in this 2 product of monomials here, we're going to deal with the power first and then multiply, following the order of operations. So we have 3 square x to the 3 times 2, which is 6y to the 2nd power, times x to the 4th y to the 3rd. Okay, let's simplify. We have 2 to the 5th, which is 32. Multiply 2 by itself 5 times, x to the 10th, y to the 5th, minus 3 squared is 9, x squared, y squared, times x to the 4th, y to the 3rd. Okay, so we're going to multiply these two monomials on the right before we subtract, following the order of operations. So we have 32x to the 10th, y to the 5th, minus, there's a 1 here, 9 times 1 is just 9, x to the, you add the powers, 6 plus 4 is 10, and then y to the 2 plus 3 is 5. Now take a look at these two monomials we have here. Are they like terms? The answer is yes. How do we know? Coefficients are both rationals. We have identical variables, and each variable has the same power. Okay. All right, so just combine the coefficients, drop the variables, and that will be that. 32 minus 9 is 23. So we have 23 x to the 10th power, y to the 5th power as the answer to question number 14. Alrighty, so it's now time for you to demonstrate mastery of the problems that we just did. So these are 14 practice problems we'd like you to try out. So the goal is to simplify the following. What we'd like you to do at this time, go ahead and pause this video presentation and solve these problems. And then when you're done, click on the play button and the answers will be displayed. Okay? Alrighty, so hopefully you had a chance to try the problems. These are the answers to the practice problem. Question number 1 is x to the 16. Number 2 is c to the 4th power d to the 12. Number 3 is negative 5m to the 9th n to the 3rd. Number 4 is 16x to the 16th power, y to the 4th. Number 5 is negative 64x to the 9th. Number 6 is 1 over 9, a to the 12th, b to the 14, c to the 16. Number 7 is 25, positive 25, a to the 8th, b to the 12th. Number 8 is negative 27, x to the 15, b to the 6th. Number 9 is x to the 14th power, y to the 13th power. Number 10 is a to the 7th power, b to the 6th. Number 11 is 64 a to the 10th power, b to the 8th. And then number 12 is 16a to the 17th power, b to the 5th, c to the 6th. Number 13 is 19a to the 14th power, and then number 14 is 44 x to the 12th, y to the 3rd power. Okay, so there goes the answers to the practice problems. So how well did you do on these practice problems? Well, let us know by placing your comments, your performance in the comment section below. And if there are any questions that you have about any of these answers that we provided, or if you like clarifications on any of the questions, just let us know in the comment section below, and we'll try our best to assist you. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your studies of properties of exponents, to give us a like or thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about what we covered in this video, or any math concepts in general, just place it in the comment section below and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to future uploads. We upload videos to our webpage, our YouTube page on a weekly basis, so subscribe to get notification of those uploads. More support resources can be found in the links in the description below, or just visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.